All right, I guess we'll get started. So good morning, everybody. I've been asked to give an announcement by the School of Computing to advertise a distinguished seminar series. This one in particular may be of interest to some of you anyway. So Humam Saknini is a Queen's alumnus. He's currently the president of King Games, which are the makers of Candy Crush. He's going to give a talk next Thursday. It'll be a virtual event. If you want to attend the event, you can register at cs.queensu.ca. And I guess he's going to talk about his time operating, I guess, one of the biggest mobile game companies in the world. They were bought by Activision Blizzard. Microsoft bought Activision Blizzard, so I guess they're now owned by Microsoft. And I guess if you're interested, just register for the talk so that you can get into the Teams or the Zoom call seamlessly. All right, so picking up with where we left off from last day. So we were just about to talk about static factory methods. So a static factory method is just a static method that exists in a class that happens to return a reference to a new object. So that's why it's called a factory method. Right? So it's a method that makes a new object and returns that object back to the caller. And you can use static factory methods to create a method that looks or behaves a lot like a constructor. Right? So remember how constructors work. Constructors initialize the state of an object. To use the constructor, you have to call new, right? And then new returns a new object back to the caller. So a static factory method is similar to the combination of new plus the constructor. Now the difference is you can give any name you want to a method, right? Whereas with the constructor, you have to use the name of the class for the name of the constructor. All right, so static factory method. So for our point class, we can create a method. Oh, sorry, suppose you want to provide a way for people to make a point where the coordinates of the point are specified in polar form. Right? Now, so you're all engineers, so I know you know this, right? So the polar form of a point, right, is specified by its angle from the x-axis and the distance from the origin. Right? Coordinates of the point are just the point on a circle, a radius r. Right? Now, suppose you wanted to provide a constructor in your class that could make a point given its polar form. Right? So what would it look like? Well, it would look like the second one down here. Right? So it's a constructor, so returns nothing. Right? Its name is the same as the name of the class. Has two inputs, or two parameters, r and theta. Both of the values are doubles. How do you make the point? Well, you did the x-coordinate of the point is just r times the cosine of theta. The y-coordinate is just r times the sine of theta. Right? I'm going to chain to that constructor there. Right? So I'm using this and then the two arguments inside round brackets. But there's a problem. Right? So the signature of this constructor is 0.2, double, double. But I already have a constructor whose signature is 0.2, double, double in the class. Right? So I now have two constructors with the same signature, which is illegal. Right? So in other words, I cannot provide the second constructor in this class, right, if I want people to make a point in polar form. So what's the solution? The solution is to create what's called the static factory method. Right? So you eliminate the second constructor, or you don't eliminate it. You replace the second constructor with a method instead. And it's a static method. Right? So it's static because the method belongs to the class. Right? I don't need another 0.2 object to make a new 0.2 object. Right? I just need the class to make a 0.2 object. So I can make the method static. The method will return a new object. So it's going to return a new 0.2 object. Right? And inside the method, I'm just going to make a 0.2 object, set the coordinates of the point to the appropriate values, and then return that object. So this thing here has a name in Java. So it's called the named constructor idiom because it's a method that looks like a constructor, right? But it's a method, so it has its own name, right? Thus named constructor. So the advantage of this over a plain old constructor is that you can give it whatever name you want, right? And you can give it a very descriptive name, so anybody who looks at the name of the method knows immediately what the method is doing, right? Unlike the constructor, where it's just the name of the class all the time. Right? So instead of having a second constructor, I replace it with a static factory method. Right? So it's public, anybody can use it. It's static, right? Returns a reference to a point2 object, and now I can give it whatever name I want. Right? So I can give it the name polar. Anybody using this method who knows about polar coordinates knows immediately what this method's going to do. Right? I can have 2 double inputs. Well, this is fine now, right? I couldn't do it before because that would have been, I couldn't have had a second constructor before with 2 doubles because I'd have 2 constructors with 2 double inputs. Right? But I can certainly have a method with that name and 2 double values. Right? And then the implementation is straightforward. Right? Just compute x and y, and then make a new point and return that point. Right? And so that gives you a way to create what looks like a constructor, or what more or less behaves like a constructor, but it has whatever name and whatever parameters you require. If you poke around in the point2 and the vector2 classes, that trailing D is not supposed to be there. So if you poke around in those 2 classes, you'll see that there's a bunch of static methods, and they're all factory methods. So let's take a quick look at some of those. Right, so in the point2 class, if you look over here in the outline view, right, anything with an S beside it is a static method. Right? So there's a static method called add, there's one called subtract, multiply, divide, and negate. Right? And there's a corresponding non-static method for all of these. Right? So there's an add method here, there's a subtract method here, a multiply, a divide, and a negate. Right? So all those are non-static. Now let's look at what the non-static add method does. Right? So the non-static add method does, it takes the point, right? Adds the vector v to the point, and it returns the same point. It returns the modified point. Right? So all the method does is it adds the x component of the vector to the x component of the point, the y component of the vector to the y component of the point, and returns the point back. Right? So that's like writing, so if you wrote p dot add v, right? That's similar to mathematically writing, or I guess writing, if you were to write this as a mathematical expression, you did something like that. Right? So add v to p and then store the results back in p. Now, the static version of add does something slightly different. Right? So this one takes a point as an input and a vector as an input. It then adds those 2 things together, returning a new point. Right? So this one, so point 2, add p and v, would be similar to writing q equals p plus v. And I guess you would want to write q up here. Right? So the non-static version changes the point, that was used to call the method. The static version does not change the point used to call the method. Instead, it returns a new point. Right? And sometimes you want the first version, and sometimes you want to use the second version. Right? So that's why there's 2 different versions of the add method, one of which is static inside the class. Right? There's no way to add, so there's no way to put in a second add method that looks the same as this, but returns a new point, right? Because it's going to have the exact same signature as this version of add, right? So we have to add a second we have to either create a different version of the add method with a different name, or we can create a static factory method. Okay, so the static factory method, so there's the explanation of what's going on, right? So the non-static versions, they're like writing p equals p plus v, and the static versions are like writing q equals p plus v. Okay, so in the standard library, there's many, many, many examples of static factory methods. Right? So in the integer class, there are several methods called value of, and they return an integer object representing the value of I. Right? And there's more than one version of it. Right? In arrays, so arrays is a utility class that operates on Java arrays. Inside that class, because it's a utility class, it's all static methods. Right? Some of them return new arrays. So copy of is a static factory method that copies the original array, returning a new array. Right? And then string also has a bunch of static methods. So if you poke around in the string documentation, you can look for those static methods and see what they do. Right? But static factory methods are very common in the Java language. Probably the most common use of a static method in the language. All right, so that wraps up the static features in a class. Anybody have any questions about either the static factory methods or something from the previous lecture? No? Okay, good. Moving on. Okay, so today's lecture then is about the equals method. So our point2 class right now, it's got some constructors, it's got a few methods in it. We haven't replaced the version of equals in the class that we got from from object. Right, so remember our point2 class, it actually inherits from this class called object. Right? If you look in the object class, there's this method called equals. Right? So what does that mean for us right now? It means that our point2 class also has an equals method. Right? What happens when you use it? Well, we can try it out. Right? So I make a point whose coordinates are 1 and 2, and I can ask, is p equal to itself? Right? Now that had better be true, right? Because if it's not, that doesn't make any sense. Right? So p equals p returns true, which is good. Right? Now if I write that line of code, you have to remember what this actually does. Right? p2 equals p. Right? Remember what that does. That does not make a second point. Right? So in this code so far, there's only one point object. Right? Because you only wrote new once. Right? New is the thing that makes a point, is the thing that makes a new object. So there's one point object. p2 equals p just means that p and p2, they both point to the same object. Right? So in other words, p2 equals p is exactly the same as p equals p. Right? So that should also print true, and it does. But if you actually make a second point whose coordinates are 1, 2, right? So in other words, same as p, and you ask, is p3 equals to p? You'll get false. Right? And that's probably not what you want for the point2 class. Right? So here's a picture of what's going on. Right? So p, new point 2, right? So there's our variable p, right? It looks like it's pointing to the object at address 600. So if you go to address 600, you find a point2 object. Its coordinates are 1 and 2. Right? When you write p2 equals p, right? All that means is p2 equals p. So you copy whatever value p has and stick it in here. Right? That's literally what it means. And now p2, it looks like it also points to the object at address 600. So there it is. Right? And then p3 equals new point 2. So now there's a new point object. Right? So the p3 points to the object at address 700, and it's down here. Right? Now notice these 2 points. Right? They have the same state. Right? Their coordinates are 1 and 2. Right? But they're distinct objects. Right? So they're 2 separate objects. The version of equals that you get from the object class checks if 2 references refer to the same object. Right? In other words, it's exactly identical to using equals equals, right? The double equal sign. So x equals y is true if and only if x and y are references to the same object. Right? So if you go back to this picture here, now the easiest way to check if 2 references are the same, point to the same object is just to look here. Right? So p and p2, they have the same value, so they point to the same object. Right? p equals p2 is true. p and p3, they have different values. Right? So p equals p3 is false, right? Because they refer to different objects. Right? So that's what object equals does. It checks if 2 objects, checks if 2 references point to the same object. Right? Now, for a value type class like point2 or date or time or something else like string, integers, stuff like that, right? All those classes represent values. So for value type classes, they should support what's called logical equality. Right? In other words, 2 objects should be equal if they have the same state. Right? So 2 points should be equal if they have the same coordinates. Object equals checks if 2, you'll often see this called equality of identity. Right? In other words, are 2 objects the same object? Right? You want equality of value or logical equality here. Right? Do 2 objects have the same state? Right? Now, if you want to do this, right, so if you want your class to support logical equality, you have to replace the version of equals that you got from object. Right? So it looks like that's what we're going to be doing for the rest of this lecture. Now, it turns out it's very common to do this. Right? So it's very common that you override or replace the implementation of equals. It turns out that for a long time, there was no agreement on how you should actually do it. This is an old quote. This is no longer true. But this is a quote from a person named Angelica Langer. She's a Java consultant. I'll just read the quote quickly to you. So one would expect that overriding equals, since it's a fairly common task, should be a piece of cake. The reality is far from that. There is an amazing amount of disagreement in the Java community regarding correct implementation of equals. Look into the best Java source code or open an arbitrary Java textbook and take a look at what you find. Chances are you'll find several different approaches and a variety of recommendations. This is no longer true. This was true back when the language first came out, and for a little while, actually, while the language was, people were still working out how to use the language. Now people have settled on two different versions of equals, and they're used in, there's two different versions, there's two different ways to implement equals. Yeah?
What is a Java consultant?
Someone who consults on the Java language. So there's lots of programming consultants. Right? So you can have there's lots of people whose job is basically to tell other companies, should they be using language X, Y, how should they do it, so on and so forth. Right? So it's actually pretty common to do, right? Because you'll have a company that's got a bunch of software written in some language and they want to transition it to something else, right? The obvious question is should I transition it to this something else or not? So it turns out if you become one of these people who are well known, for their expertise in a particular language, a lot of their work ends up being consulting work. Yeah. Okay, now, so what I'm about, oh yeah, this slide's wrong. What I'm about to do today does not always produce the results that you want. There's two different ways of implementing equals. I'm going to show you one way today. Right? But it satisfies this thing called the equals contract. Ignore the next line line's wrong. So it satisfies this thing called the equals contract. So if you go and look in the object documentation, so if we look here, so Java, and you click on the equals method, you're going to see that the description of the method is actually very long. Well, it's pretty long, right? And if you actually take the time to read it, you'll also find out that it's actually fairly mathematical. So the contract for the equals method, in the documentation for the equals method is very detailed in saying exactly what equals must do. Right? I'm going to explain all of these things to you later in the lecture. Right? So what we require from equals is the following. Right? So we're going to want four things for our equals method. Right? So an object should always be equal to itself, right? Which makes sense. Right? X equals X should always be true. X equals null should always be false, and it must never throw an exception. Right? So in other words, equals should never fail. Right? It should never fail, causing an exception in your program. If someone passes in null to the equals method, then it should automatically return false. Right? Today, what I'm going to show you is that only objects of the exact same type can be equal. Right? So in other words, only a point2 object can be equal to a point2 object. Right? So in other words, a point2 object cannot be equal to a vector2 object, for example, even though you might want that to be true. And then finally, objects with the same state are equal. Right? So 2 points with the same coordinates should be equal. 2 points with different coordinates should not be equal. Okay, so part one, an instance is equal to itself. Right? It simply means x equals x should always be true. Now, if you're writing x equals x, right, then that means x, the two things x and the input, which is also x, right, both refer to the same object. Right? Now, how do you check if two things refer to the same object? Well, you just use equals equals. Right? What are the two objects in this case? Let me scribble this down on the blackboard so I've got something to refer to. Right? So if I write x equals y, right? Then remember inside the equals method, right? x is this, right? And inside the equals method, y is obj, right? So keep that in mind. I want to check, do these two things point to the same object? Right, so inside the method, I'm going to check, is this equals to obj? Right, so the very first thing you write is, if this equals obj, return true. Right? Now, technically, this if statement doesn't have to be here. Right? So later on, so if you look at the rest of the method, the rest of the method will work if this line is not here. Right? So if this if statement's not here, your method's still correct. It's worth putting this here because it's very quick to check. Right? This equals obj, all that happens is two values get compared in memory, and then you return true if they're the same. Right? So it's very fast to check. The rest of the method turns out is not that fast to run. So it's worth checking if this and obj refer to the same object and immediately returning true. But again, it doesn't have to be there. Okay, so part 2. An instance is never equal to null. So in other words, if x equals null, if someone writes x equals null, equals should immediately return false. You must never throw an exception, right? So this means that we have to check, is that thing null? Right? So how do you check if it's null? Well, if obj equals null, return false. Right? Now, this if statement has to be here. Right? It either has to be the first or second thing you do in the equals method, because the third thing we're going to do assumes that obj is not null. Right? So in other words, if you don't check, if this if statement is missing and someone writes x equals null, then the next thing we're about to do will throw an exception, and you're never supposed to do that inside the equals method. All right, so the next part is that instances of the same type can be equal. Now this is different than the notebook implementation of equals. Right? So if you're reading the notebooks, what you're going to see in the notebooks is different. I'm going to cover that in the next lecture. So today I'm going to show you a slightly different way of doing it. So what I want to know is that thing there, right, is y a point 2 object? Right? And we don't know how to do that yet. Right? So in other words, I need to be able to get the type that a variable points to, that a variable refers to. Right? And it turns out one way that you can get the type is to use this method called Getclass. Right? Now Getclass returns something funny that you probably can't read right now. Right? So it returns this class object, and then there's this question mark extends object inside of the, for the generic type. Right? So ignore the stuff inside the less than and greater than for today. Right? Eventually, you'll learn how to read this. It's not important right now. All that you care about is that it returns some reference type called class. Right? So it turns out this thing called class is a type that represents the class of an object. Right? So for every class in your program, so point to string object, for example, there's a corresponding thing called class, big C class, that represents the class. Right? So for the string class, there's exactly one object called class that represents strings. For our point 2 class, there's exactly one object that represents, whose type is class, that represents the point 2 class. Right? So there's exactly one. The language guarantees that there's exactly one object. Right? And so so the way you use Getclass is you take your variable, so in this case obj, right, and call the method. Right? So obj Getclass returns the object that corresponds to the class of obj. Right? This Getclass returns the object corresponding to the point 2 class. Right? So I want to know, are those two things the same object? Right? Actually, I want to know if are they different objects. Right? If they're different objects, then I know that obj is not a point 2 object. Right? So I can immediately return false. So that's what that if statement's checking. Right? Is obj a point 2 object? If the answer is no, return false. All right. Now, instances with the same state are equal. So we've got a bit of a problem with our equals method. Notice what the input is, right? So the type of the argument coming into the method is big O object. Right? If I make it to this point in the code, right, what do I know? right? I know that obj is a point 2 object, right? So I know that whatever object obj refers to, it's got an x and a y coordinate, right? The problem is the compiler thinks, right, obj is a big O object, right? Does big O object have an x and y coordinate? The answer is no, right? Big O object's got nothing in it, actually, nothing that you can use, right? So as far as the compiler is concerned, obj is just a big O object, right? Down here, I somehow need to get the x and y coordinates of obj. So I have to convince the compiler that obj is in fact a point 2 object. And the way you do that is with a cast. Right? So I can't retrieve the fields of obj because it was declared as being a big O object. So I cast like so. Right? So the cast in Java works the exact same way as a cast in C does. Right? obj has type, right, has a declared type of big O object. Right? I want to reinterpret obj as a point 2 object. Right? So you just cast it to point 2. And then you store the result in a variable called other. So I always use other. You can give it whatever name you want, right? O, whatever, right? And its type is point 2. Right? So I've now convinced the compiler that obj is in fact a point 2 object. Now, if obj is not a point 2 object and you write this, then when you run your program, you'll get what's called a class cast exception, right? And you're not allowed to throw an exception from inside equals, which is why you have to check, is obj in fact a point 2 object before you attempt the cast, right? So that if statement has to be here to make sure that obj is not null, right? It has to be here because if obj is null, then on this line here, this line will throw an exception, right? Because you've got null calling some method, right? Which you're not allowed to do, right? This has to be here because on the next line I need to cast obj to a point 2 object, right? And the cast will fail if obj is not a point 2 object, right? So the order in which you write things in the equals method is very important, right? The first if statement is optional. The second if statement is not. The third if statement is not optional, and that cast is not optional either, right? You have to do all of these things, and it's always done in the same order. Okay, so I've now got this thing called other, right? So I've now got a point 2 object called other. I have a point 2 object called this. I now want to compare its x and y coordinates, right? So what I want to write, well, what you might want to write is you might want to write if this dot x is not equal to other dot x. Right? So you might want to write that, right? Which basically says if the x coordinates of the two objects are different, then the points can't be equal, so you return false. Right? So that's what you might want to write. And unfortunately, that's not what you should write in the Java programming language. Okay? All right, so it turns out there's a recipe for comparing fields. Right? So the next step is I want to compare the state of the two objects. Right? And there's a recipe for doing this. Right? So you just follow the steps one line at a time. Right? If your field is a primitive type, and it's one of the integer types or it's Boolean, then you can go ahead and write something like that. Right? Then it's fine. Right? So if x happened to be an int or happened to be a Boolean, right, or a long, then that's fine. Go ahead and do that, right? Because you can exactly compare int values. Now our problem is x and y are actually doubles. So the recipe says you should do something like this. I'll show you the code first and then come back to this. Right? So I'm going to show you the code for steps 2 and 3. 4, if your field is not primitive, so if it has some sort of reference type, then you have to decide how am I going to compare these reference types. If you have an array and you want to check are two arrays equal, right, then you should use the equals method from arrays. Right? So just go and look at the documentation in the arrays class and see how this works. It turns out it compares every element in the two arrays one at a time. If any two are different, then it returns false. Right? Otherwise, it returns true. If you have two objects that are not arrays, then just use the equals method. Right? So here you would write if this x dot equals other x, right? If x had some other reference type. Okay, now what is this float to int bits and double to long bits nonsense? So that's what it's going to look like. Right? This is what you should write. Right? It turns out this almost always works. The problem is it doesn't always work. It almost always works. So what should you do instead? You should take x, right, this x, pass it to this double to long bits method. Right? And you should do the same thing with other y. Right? So pass it to this double to long bits method and check, are those two things not equal? Right? So double to long bits, it actually returns a long value. Right? So it returns an integer value of some kind, which means you can compare it exactly using equals, equals, or not equals. Right? Now, what exactly does it do? You just go ahead and look at the documentation for double. That's probably not going to work. Sorry. Okay, so what does double to long bits actually do? Here we go. Okay, so it says it returns a representation of the specified floating point value, so it takes value, right, according to its floating point double format bit layout. Right? Okay, so a double value in Java is just 64 bits. Right? So it's just 64 zeros and ones. Right? A long value in Java is also 64 bits, right? So 64 doubles and zeros and ones. So all this method does is it takes the bits in the double value and then reinterprets it as a long. Right? So in other words, it compares if the binary representation of that, it converts the binary representation of a double value to a long value. So that's all it does. That's how it converts it to a, yeah?
What does equals equals do by default?
Equals equals, so if the types are primitive, then it compares the value of the two primitive values. If the types are reference types, then it checks if the addresses are the same. Do they point to the same object?
So for double, what's the difference between that and comparing like with one value?
So what we're doing here?
Yeah.
Okay, so I'm going to explain that in a minute. There's a lot of explanation here for what seems to be for what looks like it should be really simple. Right? But yes, there's a lot of explanation going on. So I'm getting to that. Okay. Where was I? Here we go. All right. So why do we have to go through all this trouble? Because this seems like a lot of trouble to go through, right? And it turns out the reason you have to go through all this is because of the way that the primitive floating point types are defined. Right? So the primitive floating point types, their definition is defined by this standard called the IEEE 754 standard. Right? The standard is very long, it's very dry, it's a standard, so it's very technical. Right? But part of that standard is there's this quantity called nan, not a number. Right? So this is also described in the notebook on doubles. So there's a value called not a number. And the standard says that not a number is equal to nothing, not even itself. Right? So if you take double nan equals equals double nan, the floating point standard says that must be false. Right? But the bit format of nan is the same. So the bit format for nan, there's only one bit format for nan. Right? So if you convert nan to its long value, right, and compare it to itself, then you get true. Right? So in other words, if x is nan in this example here, so if x is nan and y is anything else, then this is always false. Right? It always returns false. So x not equal to anything else is always true, sorry. Right? So nan not equal to anything is always true. So this will always return false. Right? If you use double to long bits, double nan, equals equals double to long bits, double nan, that will return true if they're both not a number. Now what about 0? So floating point 0 is weird because there is -0 and +0. The IEEE standard says -0 is equal to +0, so that returns true. But they have different bit formats. So if you convert -0 to its long value, and you convert positive 0 to its long value, they're different. So you'll get false. Right? Now, why do we care about all this? It's because if you look at the definition of equals in double, here, right? So this is the equals method from double, right? So what does it do? It compares this object against a specified object, right? So against obj. The result is true if and only if the argument's not null. That's good, right? Because that's what is in the equals contract. So if obj is null, you get false. And is a double object. So if obj is not a double object, you get false. That represents a double that has the same value as the double represented by this object, right? So are their states the same, right? So everything that we've talked about in the equals method, if you scroll a little further, there are two exceptions, right? If D1 and D2 both represent nan, then the equals method returns true, even though nan equals nan is false, right? And if D1 represents positive 0 and D2 represents negative 0, then equals returns false, even though positive 0 is equal to minus 0, according to the IEEE standard, right? So the reason you're going through all this trouble is so that you're consistent with the way the standard library works, right? So the way that the standard library works is it says that two double values are equal, blah, 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 except in these two cases, right? And you have to, it's worth putting in the effort to make sure you're consistent with the standard library. But it turns out there's another reason. Okay, so that's the mechanics of implementing equals, right? It's strictly mechanical. There's nothing really academically interesting here, right? It's so mechanical that your editor will do it for you. Okay, so here's our point2 class. I'm just going to nuke the equals method that's here. Okay, so there's equals. I'm just going to, let me just comment it out. There's another method called hashcode that we'll talk about either in the next lecture or the second lecture from now. I'm going to comment it out. And I will ask the compiler to generate equals for me. Okay. So you can get Eclipse to generate equals for you. You just go to the source menu. Sorry. Yeah, that's right. Source, right? Source, generate, hashcode and equals. Click the button, right? It asks you what fields do you want to compare in the equals method. Well, I want to compare x and y. Right? Down here, there's some options. To do what I'm doing today, you uncheck this one. So you don't use instance of. We'll do that next class. And then we'll uncheck that one for now. It doesn't matter. And then we'll generate. There we go. And then you scroll down, and there's equals, right? So it'll automatically generate it for you, right? Because it's basically a cookbook recipe, right? There's your check if if obj and this are the same object. There's your check for null. There's your Getclass. There's your cast. There's your double to long bits nonsense, right? And then finally you return true, right? So in the method here, we check, are the x coordinates different? If they are, you return false, right? Are the y coordinates different? If they are, you return false, right? If you reach this line of code here, you know that the x and the y coordinates are the same, so you can return true, right? And so that's the mechanics of implementing equals, right? To use equals, well, it's just like any other method, right? So here's my point with coordinates -1 and 1.5. Right? I make a second point q using the copy constructor, right? So p and q should be equal. Their states are equal. So if I ask, is p dot equals q true? The answer is yes, right? So you get true printed out here. All right, now, if you actually look at the documentation for the equals method, you'll see that that's the actual documentation for it. Right? It says equals must be reflexive, symmetric, transitive, consistent, and it must not throw an exception when past null. Right? If you remember what reflexive, symmetric, and transitive mean from mathematics, then it's all the same thing. Right? If you don't remember what it means, don't worry about it. I'm going to tell you what it means. Right? Reflexivity simply means that an object is equal to itself, right? X equals X is true. What happens if you write that for our point 2 class? Is equals reflexive, right? So what if I make a point 2 object whose coordinates are not a number and not a number? Oops, new point 2. I don't even have to make them both NaN. I can make one 0. It's fine. P equals X, or P equals P. Right? So what happens if you do if you write that and your equals method uses that comparison? Right? So your X coordinate's not a number. Right? Not a number is not equal to anything. Right? So this is automatically going to return false. Right? Which means P equals P is false. So your equals method is not reflexive. Right? Which breaks the contract for the equals method. Right? Does it ever happen? It almost never happens, right? The only time it happens is when your coordinate happens to be not a number. Right? And if your coordinate's not a number, you probably have bigger problems. But your equals method is still technically broken. Right? And that's why you have to go through all that nonsense of using double the long bits. Right? Symmetry. Two objects must agree on whether they're equal. In other words, X equals Y must return the same result as Y equals X. Right? If you reverse the order of the operands, you get the same answer. Transitivity just means three objects agree on whether or not they're equal. Right? So if X equals Y is true, and Y equals Z is true, then it must be the case that X and Z are equal. Right? So X equals Z must also be true. Right? So these are all the same definitions for symmetry, reflexivity, and transitivity that you might have seen in mathematics. Right? Consistency just means that equals can't be random. Right? So in other words, if you write X equals Y and you never change X or Y, then you always get the same answer. Right? So in other words, there's no randomness in whether or not two objects are equal. And finally, the non-nullity clause simply means X equals null must return false. Right? And it must never throw an exception. And that's it. So as long as you ensure that these 5 things are true, as long as you ensure that your equals method supports all 5 of these things, then your equals method may not be correct, but it's technically correct, right? So it meets all of the requirements of the equals contract. I guess one other thing to point out is that equals always looks like this, right? So if someone asks you to implement an equals method, it's always public Boolean equals object, right? You might be tempted to write public Boolean equals point 2, right? Because this is the point 2 class, right? And I want to compare two point 2 objects. It's not, what you've done is not overridden the equals method from object, right? Instead, you've overloaded the equals method. So there's 2 versions of equals now in your class, right? When you override equals, it's always this form, right? So don't change that parameter type there. How many more slides do I have? Oh, just 2 more. Okay, so I'll finish this up then. Oh, not from the beginning, sorry. Now, equals always looks the same, right? What am I doing? Maybe I should have stopped the lecture. Okay, here we go. So equals always looks the same. Right? So once you've figured out, or once you've memorized how to implement it, the first 4 or 5 steps are always the exact same. Right? So if I want to implement equals for the counter class, right, then you have to ask yourself, so when are 2 counters equal? Well, if their values are equal, it makes sense that the two counters are equal. So what does it look like? It looks like this. Right? Check if this equals OBJ. Right? In other words, do X and Y point to the same object? Right? If so, return true. Check is OBJ null, right? In other words, check is that null, right? If it is, just return false. Check that their types are the same. So this Getclass check if they're different. Check if this Getclass is not equal to OBJ Getclass. If they're different, return false, right? do your cast, and then compare your fields, right? In the counter class, the field is, the value is an integer type. So you just use equals equals, right? So I can return this value equals equals other value, right? If the values are the same, it returns true. If they're different, it returns false, and you're done. Yes?
Is this a keyword? Like, how does it know that this is the object that I'm calling it?
That's the way it works in Java. So in Java, every non-static method and non-static constructor automatically gets a parameter called this. It always refers to the object that was used to call the method, or the object that's being constructed, right? So when you write x equals y inside the equals method, this is always equal to that thing. Yeah. Yeah.
Why are you casting it to a counter class?
Because, yeah. So this is because up here you said obj was an object. So as far as the compiler is concerned, it's a big O object, and an object doesn't have a value. Yeah. So you have to convince the compiler that obj is in fact a counter, and then you can get its value. Good. Any other questions? Super. We're done for today. Next lecture, I'll show you the second version of equals, which is more or less the same as this. And then we'll talk about this funny method called hash code.